Welcome to myprojectbazaar.com. Now we can going to discuss about the product seamless transition of three-phase microgrid with the load compensation capabilities. Now we can going to discuss about the product abstract of our product. This proposed system of the product is using for the photovoltaic system and using the multiple function of microgrids. Because of this is load compensation capabilities, a lot of load compensation capabilities and some filtering process in this both process will update that in specific task. And this is operated in two conditions. For that, this is a grid connector, another one is an isolated mode. There is no interrupter in power supply. Grid connect mode and isolated mode for though no interruption in power supply. Because of seamless is an advantage of the very economic process of the objectives, and we can uninterrupted power supply. This is for two modes of operating system of the our line injections and our reactive power of also, and the grid stored of the power also. This is one of the improved method of the our battery storage system also imported that this battery storage system is on a demand response of the load or our grid also. Because of this two combination process we can getting the more performance of the result. Next we can going to discuss about the flow diagram of the product. First we can see about the solar panel. In the solar panel we can using the 72 cells of solar cell arrays. Because of this is a very important of the one of the renewable source, and the inputs are getting the irradiance level, different irradiance level to getting the input of solar panel. The solar panel we can getting purely for DC wave, and some gradually ups and downs we can getting that our DC wave. This is passed to the maximum power point tracking algorithm. This is one of the technique we can improve the result of solar power plant solar generations. And this is another thing passed to the DC to DC boost converter. This boost converter is mainly proposed to getting the very maximum power in generation in solar panel. Because of for example we can generate the solar panel 36 watts generating power. This is an maximum power point tracking with the DC to DC boost converter. You can getting the more power. For example, for more power means this 120 watt or 60 watt something varies the different levels for based on irradiance level. Then we can pass to the voltage source converter. The voltage source converter is a very important step of this process. Because of this is one of the conventional process. This is to convert the for our grid connector or isolated mode also. This is a DC to AC converter, and the DC to AC converter is passing to the power electronic switches. These switches we can some characteristics we can using that using the IGBT or MOSFET also bottom we can different switches thyristor whatever example we can using that. The switches is passing to the some conditions. This condition is act as what mode we can act as that specifically. This is a grid connector mode. Then we can pass to the isolating mode. Because of this is an PWM using this converter of the switching pulse. The PWM switching pulse can convert to the voltage source converter. Then we can calculate a voltage source converter. We can our entire system is an passed or not. Now we can going to discuss about the running process of the product. The proposed system implementation done in MATLAB version 2013A. First open the MATLAB window and create the new model file, and creating elements as per the circuit diagram of the base paper, and the corresponding scopes are connected in the as per the result of the scopes. Next we can going to discuss about the see the results. General architecture modeling. These are general architecture is on solar panel, battery, and voltage source converter, and different modelings are gathering to the as per the circuit diagram of the paper. And ripple filter, this is on load and grid we can entirely as per that we can implement it. This next we can see about the results. This is for PV characteristics. This is for PV characteristics for solar panel. The x-axis is on voltage, y-axis on power. Nearly it goes through 232 or 240 getting the maximum power we can attain that solar panel. Then next for that IV characteristics of the solar panel. This is for the x-axis is on voltage, y-axis on current. This is an IV characteristics curve. Next is see for our solar panel. This is for our saturation region and switching pulses of DC to DC boost converter. We can getting the result using the x-axis zoom. This block. Next this is for our VDC of solar panel of boost converter. We are getting that. Next we can see for our scope using the exact zoom we can getting the result. And another thing is for our IV scope, because of this is an voltage and current scope of this specific lines. This is a very noisy and very leisurely noise and very distortion this specific noise. We can, this is not getting that pure wave because of this a lot of distortions in every arc and different phases, red phase, blue phase and yellow phase also. This is a very nice. Next this is going to switching pulse. This is for our voltage source converter switching pulse. You can open that scope block. We can just use the exact zoom. We can getting that you can randomly turn on and turn off the switches for the our voltage source converter. These are 6 switches: S1, S2, S3 and S4 and S5 and S6. Then we can go into for our, these are our non-linear load. This is our switching pulse of the line. You can getting the exact zoom. We can similarly we can getting the result of turn on turn off the 3 lines of phases we can using switch. Another thing is an 3 phase ABC. ABC means 3 phase voltage. You can get daily PD sinusoidal wave of nearly 130 voltage. This is on our grid current. Daily purely sinusoidal wave. We can getting that. And this is an overall architecture modeling of the stimulus of solar panel.